Zeal Education Society, redefining excellence.
Hello everyone, I am Shreya Diggekar, first year diploma student of Civil Department from Zeal Polytechnic, Nare, Pune. My project is to explain the different types of refractory materials, and the project is guided by Professor Vidya Bhagat ma'am. Next point is refractories. Any material which can withstand high temperature, that means it is refractories. Importance in construction of metallurgy, engineering, chemical industries. Then next, my second point is introduction. Refractory is any material which can withstand high temperature without softening or suffering a deformation in shape. Main objective: first, to confirm heat, for example, to resist loss of heat. Second, to resist abrasive and corrosion action of molten metals, sludges, and gases at high temperature without undergoing softening or distortion in shape. Next, uses. First, construction of linings of the furnace, tanks, converters, kilns, crucibles, ladles, etc. Second, manufacture of metals, ferrous or non-ferrous, cement, glass, ceramics, paper, steel, etc. My third point is characteristics of refractories. A good refractory possesses following characters. First, be infusible at the temperature to which it is liable to be exposed. Second, chemically inserts towards corrosive action of gases, metallic liquid and glass. Sludge. Third, resist the abrasive action of flue, gases, flames, etc. Fourth, be able to understand the overlying load of construction at the operating temperature. Fifth, no crack. Sixth, no loss in size. Seventh, expand and contract uniformly with temperature rise and fall respectively. My fourth point is classification of refractories. First, acid refractories. Important members of this group is alumina, silica gel, fire clay refractories. Second, basic refractories. CaO, MgO. Third, neutral refractories. Made from weakly acid basic materials like chromate, FeO, CrO2, zirconia, ZrO2. Important members of this group are graphite, chromite, zirconia, and carbonundum (SiC) refractories. So next, my fifth point is properties of refractories. First, refractoriness. Second, strength or refractoriness under load. Third, dimensional stability. Fourth, chemical inertness. Fifth, thermal expansion. Sixth, thermal conductivity. Seventh, porosity. Eighth, thermal spalling. 9. Resistance to abrasion or corrosion. 10. Electrical conductivity. 11. Heat capacity. 12. Texture. 13. Permeability. So next, properties of refractory. So the first property is refractoriness. Ability of a material to withstand the heat without appreciable deformation of softening under particular service conditions. In general, measured as the softening or melting temperature of the material. As most of the common refractory materials are mixture of metallic oxides, so they do not have a sharp fusion temperature. Py- Pyrometric coins test. Sager coins test. The softening temperature of the refractory material are generally determined by using pyrometric coins test. Expression in terms of pyrometric coin equivalent PCE. Softening temperature, operating temperature. Material to be used as refractory. So the next is manufacture of refractories. Consists of following steps. First, crushing. Raw materials in the form of big lumps are crushed to about 25 millimeter size. Second, grinding. The crushed material are grinded in grinding machine down to 200 mesh size. Third, screening. Purify the refractory raw material and remove unwanted materials from the raw materials, and this is done by settling, magnetic separation, chemical methods. Fourth, storage. After screening and mineral dressing, pure material is stored in storage bins with bucket elevators. Fifth, mixing. It is done so that proper distribution of the plastic materials throughout the mass takes place. This makes molding easier. 6. Molding. Molding may be done either manually or mechanically by the applications of high pressure. Hand molding produces refractories of low density and low strength. Mechanical molding produces refractories of high density and strength. Manufacture of refractory consists of following points. In order to increase the density and strength of refractory by mechanical molding, the de-airing of refractory material is essential. De-airing is done by first applying vacuum through vents in the molds. Second, by allowing air inside the void space in the refractory to go out by decreasing the rate of pressure application and release of air. Third, by down pressing the material in first pressed and allowed to crack. Then it is pressed again so as to close the voids. 7. Drying. Removal of moisture is done under well set conditions of humidity and temperature, depending upon the types of refractories. Drying is usually carried out in tunnel dryers. 8. Firing. To stabilize and strengthen the structure of refractories, firing is done. The bricks are generally fired at a temperature as high as or higher than their use temperature. It is done in tunnel kilns or shaft kilns or rotary kilns.
Zeal Education Society, redefining excellence.